So I'm going to solve the systems of equations using substitution. Systems is when you have two equations with two different variables, usually an x and a y. And I think using substitution to solve this would be really easy because you already have a variable with a coefficient of 1, which is right here. Okay, so it'll be really easy to get y by itself in that top equation. I'm just going to take it and rewrite it over here. Okay, so to get y by itself, you need to get rid of that negative 7x. So I'm going to do the opposite operation and add 7x. That will cancel out and equal 0. So I like to just cross it out. And whatever I do to one side, I have to do the other. But I can't combine negative 19 and 7x because 7x is a variable term and negative 19 is a constant. It has no variable. So what I've done now is I've solved for y. So instead of writing y in this second equation right here, I'm going to take this whole statement, negative 19 plus 7x, and plug it in wherever I see y in the second equation. So I'm just going to go ahead and rewrite that. And instead of writing the y right here, I already solved for y. I know that y is equal to this. So I'm going to go ahead and take this whole piece and plug it in. Draw my parentheses, negative 19 plus 7x. Close parentheses, and then finish it. Okay, so now I only have one variable that I have to solve for. I know whenever I have parentheses, I have to clear them by taking that outside term and multiplying it. So 3 times negative 19, I know is going to give me a negative 57. And 3 times positive 7x gives me a positive 21x. Bring everything down just to stay organized. Okay, now I know I have like terms that I can combine on the same side of the equal sign, which would be negative 2x and positive 21x. When I combine them, I'm going to get 19x. And bring everything down that I didn't use to stay organized. Okay, now I'm trying to get x by itself, so I'm going to leave that 19x alone for now. And I need to cancel out that negative 57, so I can do that by doing the opposite operation and adding 57. That'll give me 0 and cancel out. And whatever I do to one side, I need to do the other. So negative 19 plus 57 gives me 38. Bring down that 19x. And now it's just a one-step equation. That's really saying 19 times some number, which is x, equals 38. So to undo that multiplication that we have going on, I do the opposite and divide by the coefficient of 19. That cancels out and just gives me x, and x is equal to 2, because 38 divided by 19 is 2. Now that I have a number for x, I could take it and just plug it in up in this equation that I already solved for y. So I'm just going to go ahead and rewrite that, and instead of writing x, I already solved for x, I'm going to write 2 and just plug it in there. So here we go. So notice how instead of writing 7x, which is really saying 7 times some number that we don't know, I plugged in that 2 where x was, because I know x is equal to 2. So 7 times 2 is 14. Bring down everything. And then negative 19 plus 14 is going to give me a negative 5. So I found y. Now, those two linear equations, the solution to that is where the two lines intersect. It's the only point they have in common. So I'm going to go ahead and write this in an ordered pair form. I know the x coordinate is first and then the y. So I'm going to go ahead and put 2 first, comma, negative 5. Okay, so that is the point on the coordinate plane where those two linear equations intersect or cross right at that point. Okay, thanks for watching.